Now I get to introduce myself. You already met me, Elizabeth Mitcham from University of California, Davis, where I direct the Postharvest Technology Center and the Horticulture Innovation Lab. I'm going to shift gears a little bit and talk more about technologies that may be helpful for horticultural products after harvest, and talk a little bit about why markets are important for their adoption. Okay, so we've been talking a lot over the last couple of days about post-harvest handling, and of course, doing a good job with post-harvest handling really can make the difference between success or failure and the amount of income that farmers might make from their products for themselves and their families. And of course, very important for reducing costly loss and waste, and we've talked about the importance for sustainability and food security. But doing a good job in post-harvest handling is really important to meet the demands of the market. At the same time, having a market will allow may allow farmers to be able to actually invest in doing a better job with post-harvest handling. So really the two can very much be intertwined, and in some ways it's which came first, the chicken or the egg, the market or the good post-harvest handling. As we look at post-harvest handling around the world, and we've seen a lot of examples, we see a lot of room for improvement, a lot of less than desirable practices in terms of how product is handled. Some of the main causes of post-harvest loss, I believe, for horticultural crops are related to high temperature, physical damage, water loss, decay from pathogens, and also inadequate drying and dry storage for products that are dried. And these are all interrelated because water loss is actually exacerbated by high temperatures and also by physical damage, and decay is also exacerbated by high temperatures. So the presentation this morning set me up very nicely for this part of the talk, where I'm going to talk about the lack of cold chain. And I wholeheartedly agree that we need to address this issue in some way. It's just impossible to think that we're going to be able to feed the world without having access to the cold chain. We're never going to reduce post-harvest losses without it. As I said before, it's related to water loss, decay, also can reduce over-ripening of products. Without cold storage, the amount of time you have to market a horticultural product is greatly reduced. This puts farmers in a very precarious situation where they really are price takers. They have no control over who they're going to, or very little control over who they're going to sell their product to, because they have to sell it today or maybe tomorrow in most cases, otherwise the product is ruined. The other thing, the lack of the ability to hold product prevents farmers from being able to accumulate a quantity of product that might be required by certain buyers. And so that can limit their ability to get into a market. So if we look at post-harvest handling, this is just an example from some data from Kitnoya and Al Hassan in 2010, just showing that even though we know tomatoes should be held at 15 degrees, in many parts of the world, they're generally at twice that temperature. Post-harvest handling around the world has developed all sorts of cooling methods, and most of these, of course, are of the wrong scale and the wrong technology for the developing world at this time. But it doesn't mean that cool storage is not feasible, I believe. Things as simple as protecting the product from the sun can have a big impact. Certainly it's not cooling, but it prevents the product from heating, and can be a range of different types of structures, something as simple as an umbrella over the product after it's harvested. I wanted to talk about low-cost cold storage technology that's related to CoolBot controllers. The CoolBot is a controller that's developed by a US company called StoreCool. It works with a regular air conditioner unit to allow that unit to cool down to between 0 and 2 degrees Celsius. And you match that up with an insulated room, and you can have a cold room for relatively low price. So the way the controller works is it tricks the air conditioner by heating the thermostat, so it thinks it needs to continue to cool. We can put a room like this together. It depends on the cost of the insulated panels, but certainly for about $4,000, maybe $8,000, depending on the location and the sophistication of the room, you can put a 6 megaton capacity unit together. So it's certainly a hurdle still. It's a lift for many farmers, but it's a lot less expensive, about 90% less than a commercial cold storage system. We've been working with these in a number of places around the world, as have others. One project we're particularly interested in is some work we've been doing with SIP in Bangladesh, looking at potato storage. We've effectively stored Irish potatoes, seed potatoes, and also sweet potatoes in these cold storage rooms for more than 6 months. And they can be run on solar power. Of course, that does increase the cost, and we're looking into battery technology to put together with those solar panels. The benefit of this, though, is that it then takes that monthly cost of the electricity out of the equation and makes the unit eventually more sustainable once the initial costs are borne. However, there are also lower technology systems that are also available that are based on evaporative cooling. So this is based on evaporation of water that cools, and you're probably familiar with charcoal coolers, and you may have heard of the zero energy cooled chamber, or the ZEC as it's called. The ZEC was developed in India by a scientist named Dr. Roy, and this picture shows Lisa Kitnoy and some of the colleagues from India with one of the ZECs. Now with these, you can cool the product about 10 degrees below ambient temperatures. Particularly works good in dry climates, and it certainly is less expensive to build, although the capacity tends to be lower. Packaging is another technology that's really needed, protecting the product from damage and also reducing water loss. You see all sorts of examples of really horrific packaging and compression damage and crushing of products all over the world. I'm very happy to learn that plastic crates, which we've long thought were just the right answer, reusable plastic crates, are now being manufactured in Africa. One example is this Agro-Z crate that is made by A to Z textile mills in Tanzania, and it is starting to be adopted by particularly export growers of some of the fruit crops, but hopefully this will eventually penetrate to other levels of the agricultural industry. Water loss is also a big problem, especially for leafy greens. Really, plastic bags are the best way to reduce water loss because they keep the humidity high. The challenge there is that, so these are just some examples of plastic bags, but this is the problem. Plastic bags, because in many parts of the world there's no waste pickup, there's no trash collection system, and these bags are not biodegradable, or at least the ones that are biodegradable are too expensive, and so this can be a problem. Quickly, I'd like to talk about drying and dry storage, which we've coined the term the dry chain to kind of go along with the cold chain, and I think for dried products, it's just as important to maintain quality. So, and really it's important, for a lot of the commodities we're talking about here at this conference, in addition to dried fruits, dried vegetables, and nuts, it's also important for grains and legumes. It can be really challenging to dry these products, especially in warm, humid environments. And the thing is, once they're dried, assuming you can get it dry, you have to keep it dry. And if you're not storing it in a moisture-tight container, it's not going to stay dry, and that's going to lead to mold and aflatoxin contamination. So, and this is just talking about how if you really get the product down to the right moisture level, you can eliminate the activity of insects and molds. So you really can prevent aflatoxin from further developing and insects from growing. So solar drying is one technology that has been used for a variety of crops. I see it now being talked about for some of the grains as well. In our program, we've been looking at solar drying as a way to sort of stabilize products and provide some off-season access to nutritious horticultural crops. Some of the researchers at UC Davis developed this improved solar dryer that's called a chimney dryer. This was us testing it in Bangladesh about a year ago. The way this technology works is it has a chimney at the end that acts as a wind tunnel, and the hot air, the air is heated from the sun, and the hot air flows along the platform here where the product is on trays. So the air is passing through a very narrow channel where the product is, and then the chimney helps to give you more airspeed to kind of drive the air up and out. And so you get higher air speeds, higher temperatures, and generally more efficient drying. So we've actually been working together with Liz Ann Wheeler and Lisa Kitanoya and the WFLO to test some of these technologies in several different countries and climates around the world. Some of this data has been updated based on those results. But we find that the chimney dryer is a little more expensive to build, about $652 to build versus $507. And this is on average in a range of different countries. But the capacity of product you can put in is about double, and the rate of drying is much faster. So we found that the time to dry to 10% moisture content for the chimney dryer on average was about 2 days, whereas for a standard cabinet dryer with a small chimney on top, it was 3 to 5 days. I'd also like to mention some ceramic drying beads that we've been working with, and these drying beads absorb water very tightly and very efficiently, so they can actually pull the relative humidity in the atmosphere down to close to 0%. And we've actually, we had been testing this for horticultural seeds to maintain the quality of the seeds, and we're continuing to actually scale this out for that purpose. But we've also been looking at using it for some horticultural products and also for things like groundnut, for example. So we have some processors in Bangladesh who are going to use these drums here. You put the beads in the center and your groundnuts around it on the outside. They're going to deliver these out to their growers, who will then, after doing some initial drying with the sun, they'll put the groundnuts in the barrels and then send them into the processor. We figure by the time they get to the processor, they'll be pretty close to the appropriate moisture content. So we're very excited about this technology, and we're working in Bangladesh to try and scale that up with seed companies and also processors. Okay, so I've mentioned several technologies that really are important for horticultural crops in terms of maintaining quality. But we've known some of the things that we think needs to happen to improve post-harvest handling, but why has adoption been so poor? I just have a few ideas to share on that. Here we have a picture in Bangladesh of some flower collectors. It's a collection facility for cut flowers. And some donor, I'm sure, had come in at some point and put in these beautiful stainless steel tables, and yet the flowers are still on the floor and the people are sitting on the tables. So what happened there? I mean, why is there a lack of incentive to actually utilize the technology that is there, the improved process? Is it a lack of incentive, a lack of access to market, or will the market actually pay a differential if you do a better job? Is it a lack of resources or capital in some cases? Lack of information, training, or are there other reasons? I think it's very important to have any potential to have post-harvest practices improved. Growers need to have some idea that they're going to see a return on their investment, whether it's an investment in their time or their money. And I think access to a good market is critical for that. Some of the post-harvest technologies, as I said, can actually help them access markets by allowing them to pull product together and have larger quantities by holding it a couple of days, give them more negotiating power with buyers. But it's a little bit of a chicken and the egg kind of thing, as I said before. I do agree that farmer associations are really important. So I need to quickly hurry up, I'm out of time here. So we have been working with savings groups to try to encourage saving of resources that could then be used to invest in better post-harvest practices, and adding that along with training about post-harvest management. And so basically the post-harvest principles, or things that I've gone through in terms of temperature management, protecting from damage, some of these can actually be implemented with very little investment, but farmers still need to have an incentive because it all takes more time. So I think with that, I'm going to go ahead and close. And unfortunately, I've run myself out of time for questions, so I'm going to go ahead and, in the interest of our other speakers, move us along. So thanks for your attention, and I'll be around during lunch. If you have any questions or comments, I'd love to hear them during lunchtime. Okay, so actually,